quick summary of the topics that are going to be in your midterm. Your midterm is going to consist of 10 section 1 questions, which are multiple choice, A, B, C, D, and you only pick one answer, and I don't want to see working. And then a section 2 where I want to see working. So starting in week 1, we did radians.
And how many are in section 2?
10.
10
okay. Questions in each. So in week 1, we did radians, degrees, and coterminals. That was things like turn 60 degrees into radians, turn pi upon 4 radians into degrees, and 400 degrees, it's too big, so call it 40 degrees, things like that. Arc length and area sector formula. Remember, arc length was r theta, and the area of a sector was 1/2 r squared theta. And make sure that everything's in radians when you use that. And then we did a whole load of right angled stuff. Basically SOHCAHTOA, didn't we? Right, and using the inverse sine function to find missing angles and finding heights of castle walls and puzzles like that. And we went and moved on then to, if I told you that the sine of theta was 4/5, could you find the other 5 trig ratios, things like that. And we then did triangles that weren't right angled. And remember the sine rule and the cosine rule, right? And we talked about if you were given a triangle and I gave you certain information, like maybe a side and a couple of angles, whatever it was, you should be able to find all the other angles and sides. And the cosine rule was used only in 2 specific circumstances. If you knew all 3 sides, you would use the cosine rule to get the angle. And if you knew 2 sides and the angle in between, you would use the cosine. And that's what that was about. And then we're kind of on to the unit circle, which I hope you've got a good copy of, because you will definitely be using it a lot. The 6 trig ratios.
I have a question.
Yes.
So what sort of notes are we allowed to have?
Anything that's physically written down. So if you've written notes like, what would that be? Like SOHCAHTOA, and you've wrote the formula, right? Or the area of the triangle, that's allowed. Or a unit circle, that's allowed. But you could also write down things like examples of types of questions.
So do we have to hand draw the unit circle, or would
no,
be allowed?
No. You will just use it. I won't ask you to draw one. You'll just use one.
So if I have like a screenshot of work you've done in class, is that fine?
I don't know about that. That's pushing it a little bit. It has to be physically written down to be safe. So it has to be notes that you've written.
Okay.
So in most cases that are not unit circle, it must be a written down thing.
Yeah, I mean, if you got a question like, what's the exact value of the sine of 45 degrees? You would just go to the unit circle and you'd write down the answer, correct? But that question would almost always be in the multiple choice. So you would just pick A, B, or C. So I wouldn't see working anyway, right? So the unit circle that would be an example of not needing working. But can you imagine you did a question where I wanted the exact value of something, right? And it was SOHCAHTOA, but I told you the angle was pi upon 3. Couldn't you get the exact value then by using your unit circle? But wouldn't there still be a lot of work in SOHCAHTOA? So you'd still have working to show. So if it's a simple question, yeah, you'd probably just be telling me the answer. Now, where was I? And we'll come back to these because these are questions you can ask. We did a whole load of trig graphs, haven't we? Phase shift, amplitude, period, frequency, and things to do with that. If I gave you a function, could you tell me all those properties? What's the amplitude, phase shift? And occasionally you might even get to sketch. So that's a kind of rundown of all 5 weeks. Have you noticed that the trig identities is not part of this midterm? Right, I know we did it yesterday, and it's not even part of this week's homework. Hopefully you can keep that in your head for a little bit later. I'm going to be taking my what do you call it? They have a name for it. Personal day. I'm going to be taking my personal day off on Tuesday. So there won't be any class on Tuesday. So that week's going to be quite short for you because Monday's your midterm, Tuesday I'm taking off. And I'm not taking it off so I can go to Vegas. I'm taking it off so I can grade all your stuff. And I want to get it done and back to you as quick as I can. So my personal day will be Tuesday.
So there's no class Tuesday?
You nailed it. No class on Tuesday because of that. So I won't after the midterm, I won't see you until the Wednesday of that week. Right. That's a quick kind of shortcut summary of what we've got. Now we are ready for, can we go over questions like this, or could you explain that again to me? So I'm open to you tell me. Ask me some questions.
So when we're using Microsoft Lens to create PDFs,
yeah.
So we take pictures and then is it possible to merge them all together to make one large PDF?
If you take a picture, then another picture of the next page, then a third, and a fourth, and a fifth, and when you're finished, then you can say I'm done, and it will merge them all together as one.
Okay.
Any other questions? Now, it could mean that you have nothing that bugs you and you know everything perfectly, which would be great, but probably not true. So, I mean, I can pick topics, but really.
So on the practice exam,
yeah,
there's two questions, number 5 and number 6.
Okay.
Which
Tell me 5. And
5 is
right.
The exact value of sine of 30 degrees plus cosine 150 degrees is which of the following?
Right.
And I eventually figured it out.
Okay.
With Googling. But
you don't want to have to do it that way. You're not allowed to do that in the test either.
But that's the thing I was wondering is like how, like.
Okay. This would be a classic example of your unit circle. If I got my units, I do. Here we go. Here's my unit circle. Is it the X or the Y coordinate that gives you the sign? Can you remember which one it is? The X or the Y coordinate that gives you the sign?
The Y.
So I find the Y coordinate of 30 degrees and it ends up being a half. So that's a Y coordinate. And for the cosine of 150, isn't that the X coordinate? So I'm going to find the X coordinate, and I believe it's that guy. So far, so good. So the exact value are these fellas. Now, since they both share a 2, there's my answer.
Can you hear me now?
I can. What'd you do, Ali?
Hallelujah. So I just went on like the browser and went through Zoom that way because I tried using an app on my computer and I guess it's just not working for me. So,
well, I'm glad you did it because you won't want to turn up on Monday and be desperate to ask me something, but you know, it never happened. Right? Are we comfortable with this one? Let me pick one up right off the top of my bat of a similar kind of question. Suppose I said to you, I want to know the exact value. The word exact means no decimals, right? Square roots and things like that. And I said to you, I want to know the exact value of this guy over that guy, right? So I'm just picking off the top of my head an expression. And this question here could be done in a section 2 because there is a little bit of working. It could also be in a multiple choice, couldn't it? Because, you know, there's one answer and there's only one answer. Now, if you find the sine of 45, which is here, it happens to be root 2 over 2. If you find the cosine of 45, which is the x coordinate, it's root 2 over 2. And if you want the tan of 45, you have to know that the tan of 45, or any angle, is the y coordinate divided by the x. In this case, root 2 over 2 divided by, guess what, root 2 over 2, which is 1. And then these two multiply together and give me the square root of 2, which is 4, and the square root of 4 is 2, I should say. And 2 times 2 gets me 4. And that gets me a half. So that guy, as an exact value, would be a half. Okay, what was question 6? Is it the same kind of question?
Yeah, it's the same kind of question. It's the sine of 30 plus the cosine of 120.
Okay,
And
let's keep going.
the explanation I came across for that eventually, strangely, kind of a strangely involved way of going about it, because it has a thing where it turns the cosine into a negative.
Oh God, no.
And then it says
Yeah.
that the cosine is actually, it's negative cosine of 60 rather than plus cosine of 120. It's a very kind of convoluted explanation.
I think the moral of that story is not all things on the internet are helpful. Sometimes you look up something and instead of helping you, it hurts you. This is not as hard as they're making out to be. The sine of 30, isn't that the y coordinate again? So on my unit circle, the y coordinate is a half. Now, what's the cosine of 120? There's 120. And the cosine of 120 is the x coordinate, right? And what's the x coordinate? Oh, negative a half. Answer is 0. Wasn't that a lot cleaner than the sounds like the convoluted way they were trying to get you to do? Now, as long as the angles are in your unit circle, can't you just use x and y coordinates when it's sines and cosines? And when it's tangents, don't you just find the y and divide it by the x and simplify it as best you can? And that's what you would do for the tangent. So if somebody says, what's the tangent of 330? It would be negative 1/2 divided by 3, root 3 upon 2. And that would simplify down eventually, I think, to negative root 3 over 3. Okay, next question. First, has that answered your problem about how you do those?
Yeah, that's good. Thanks.
Right. Much easier than you thought it was going to be, right? Okay, what's next?
I still really have a hard time understanding inverse sine and inverse cosine. So the assignment that we just did.
All right. I'll start with a simple one and then work our way up. If you were being asked to find, and it's always exact values of this unit circle again. Right. So what you're going to be looking at essentially is what angle has a sine of root 2.2. And so since it's a sine, isn't that what angle has a y coordinate of root 2.2? And if I look at my unit circle, would you agree that there are 2 possible answers? Pi upon 4 has a y coordinate of root 2.2, and the other one is over here, and that's 3/4 pi. But only one is correct. And to do that, you need to know the range of values that you're allowed for the inverse trig function. So here goes. The inverse sine function. You can only use answers in the range negative pi upon 2 to pi upon 2. And that's also for the inverse tan function. So if you've got 2 choices, as I do here, you must pick the one that's in this range. And that makes it that guy. If you are doing an inverse cosine function, then you must pick angles in that range. And if you're wondering where is this coming from, these are the ranges of the function. And when you do an inverse sine function, this guy is negative pi upon 2, right? And this guy is pi upon 2. It looks something like this. And the inverse sine function kind of looks like that. And so you're restricted to here to here. So that guy is why you pick answers from there. Now, if you make it a little bit harder and someone says to you, well, I'd like to get the inverse sine of the cosine of pi upon 3. Then again, where's my unit circle? The cosine of pi upon 3. What do I know? Pi upon 3 is here, and the cosine is the x coordinate. So you've now asked me to find that guy. Great. Now, what angle has a sine equal to a half? So I'm looking for a y coordinate of a half. And when I look at it, the answers I get are pi upon 6, and there's another one over here, 5, 6 pi. Which of those two do you choose as the correct answer?
Pi over 6.
And the reason, because it has to be in that range. So far, so good. Right, let's put in an inverse cosine, and I want to find the sine, and I'm going to do 7, 6 pi. Right, the first bit is a number that you get straight from here. So it becomes the inverse cosine of 7, 6, which is this, and a sine is the y coordinate. So it ends up being that. Now, when you're doing an inverse cosine, you are looking for an angle that has an x coordinate of negative a half. That's kind of how you think about what this is. You're finding an angle whose x coordinate is negative a half, right? Because the x coordinate is what the cosine would be. Now, if I look at this and I look for who has got an x coordinate of negative a half, do you see I've got one up here, which is 2/3 pi. And if I look a bit further, there's always a second one. There's a one down here, which is 4/3 pi. But only one of them is the correct answer. And when you do inverse cosines, oops, put too many there. The range is 0 to pi, right? So in this case, you pick that one. Right? That's 0 to pi, that's too big.
All right, thank you.
Right. So, you know, these questions and unit circles go really hand in hand, don't they? You know, you really need this, and you need to understand the different kinds of information that are contained here. Can't I use this to find the exact value of the sine of 45 degrees? But couldn't I also use it to find inverse sine of a half? Right, I can use it in two different ways. But when you use inverse sine functions, there's going to be two possible answers. And so we have a rule that tells us which of the two you should pick.
So what if you're trying to find like the inverse cosine of 5, a value that's not going to be on the unit circle?
Oh, that's a very easy question. The answer is it doesn't exist.
Okay.
Is that okay? It just means it doesn't work, right? And that's okay, because DNE is allowed. I think, don't they? I can't remember. What did they don't use does not exist? What did they use in WebAssign? Don't they have a word? Undefined or something? Right. They have a sentence like that in it, and that's the word that you use then. Right. That's good. Nice, short, but good question, because I bet you that will happen for other people. What else?
Actually, one more thing on that topic.
Okay, good.
So a homework question that I was confused on says it's asking the tangent inverse of the square root of 3. Okay,
so we are looking for an angle that has to be in the range negative pi upon 2, because that's the same thing that's true for the inverse sine. So I am looking for an angle, right, whose y coordinate divided by the x coordinate is root 3. It's kind of easy when it's just an x and a y, you can see it. It's a little bit trickier when it's this. So as I scan through these choices, and I'm just picking one at random, if you take the y and the x coordinate of this one, So it's a half over root 3 upon 2. I'm going to calculate that. And if it happens to equal this guy, I found my answer. And if it's not, then I'll try the next one. I kind of get used to these because I've seen so many in my life, but I know that's not going to work, but I believe it's not going to work. So it's a half divided by root 3 upon 2, which is a half times 2 over root 3. They cancel, and the answer is 1 over root 3. If you rationalize the denominator, nope, it's not that one. Do you notice I only picked ones with root 3s in them? So I'm not going to even bother looking at that one or that one. I'm going to look at this one next. So root 3 upon 2, that's the y coordinate, divided by the x coordinate. Top fraction divided by the bottom. Top fraction times the reciprocal. Bingo. So the answer that we found was that this one, the y divided by the x, gets you that. So that makes it pi upon 3. Now, if that one didn't work, wouldn't I try this one and then eventually try this one? Eventually, wouldn't I, if I tried hard enough, wouldn't I eventually get one? Maybe one down here is the one that worked. But one of those y divided by x's would eventually get you the square root of 3. And you only choose answers that are in the range of negative pi upon 2 to pi upon 2, which actually means I should only choose guys in the first and the fourth quadrant. And how do you get negative numbers? Well, just pretend that it's 330 was the right answer. We would call that negative 30 degrees then, or negative 11.6 pi if you want radians. So you could get a negative answer. It just means that the angle is in the fourth quadrant.
Awesome, thank you.
Good.
And we would just do the same thing for like inverse tangent of -1, right? Just
Yeah, same kind of thing. Inverse tangent of, well, there are not that many inverse tangents, are there? It's just like there's not that many things that the inverse sine can equal. So yeah, I was trying. I guess 0 is another one. Can you have the inverse tangent is 0? That could be a chance as well. And you would, that one would be a little bit easier to figure out. Another topic. Right, let me, just while you're thinking, draw some triangles. You're just kind of random come into my head triangles, and very often what you get in these questions is they ask you to find all the missing sides or angles, or maybe just one particular one, right? That's more likely, right? So let's look at this first triangle. If I asked you to find angle A, sine rule, cosine rule, or SOHCAHTOA? Triangle, this one here. Angle A, sine rule, cosine rule, SOHCAHTOA.
Cosine?
Agreed. What was the clue? How did you, you're right. What was the clue?
You don't know any angles and you have all three sides.
Yeah. That would be that one. Suppose I was doing this one and I asked you for that third side, the one I put a little asterisk on it. What method would you use to find that one?
couldn't you just use the Pythagorean theorem?
That's exactly what I wanted to hear, yes. If I asked you only to tell me that angle, right? So I didn't want to know this side, but only that angle. What would I use now?
SOHCAHTOA.
And which one of the three would be working for that particular triangle?
Tangent.
Okay. Agreed, opposite, adjacent, tangent, right? This triangle looks at first sight to have a problem. Like, you haven't told me enough information. I want you to look at this triangle again and pay attention to those funny little marks on these two sides. When you see that, what's it telling you about these two sides?
Aren't they the same length?
That's what the symbol means. Those little dash things mean I'm the same size as the other guy. Now, is there any angles in this triangle that you can fill in before you even worry about the question?
Can't you get all of them?
You can. What's this angle going to be?
Isn't that 130?
Okay, and what's the one that's left?
120.
If two sides are the same, aren't the two angles the same? It's called an isosceles triangle. And if you know those two are 30, isn't that what's left? Now, in this question here, couldn't I ask you to get X? Right? In fact, imagine the question was find X. Do you see that what you have to do in that question is realize just because you haven't been told these two angles, don't you sometimes have to fill them in anyway before you could get the question? See, if you just looked at this question like that, would you agree there's not enough information yet to find the missing side called X? But if you fill in these angles, isn't there now enough information? Sine rule or cosine rule? How would you find X on this triangle?
Cosine rule?
Couldn't you use either?
Well, I guess that's a good question. Could you?
Well, you probably couldn't because you need to have
Two sides and an angle in between, yes. So this one would only work if you did the sine. And if you picked the wrong rule, if you did the sine rule, you'd find out, or the cosine rule, I should say, if you wrote down the cosine rule, whatever version you thought was the appropriate one in this question, you would realize, wait a minute, there's two things missing and I can only do it when there's one thing missing. And it would probably come to you. In this question here, suppose I asked you to find the length of this side here, I'm calling it little b, probably because that's big B. Sine rule, cosine rule to find this missing side. Which one would it be? Sine rule or cosine? Correct. What was the clue? How did you know?
You have two sides and an angle in between.
Right. So try and remember that. Three sides, cosine rule. Two sides and an angle in between, cosine rule. Any other combination, if it's doable, is going to be a sine rule. Now, let's suppose I found that guy and it ended up being 12, just for argument's sake. Couldn't you now find A and C? You know, angle A and angle C. Right. So sometimes you get a question where you might do a cosine rule at the start, but if you wanted to find the other things, it's easier to do the sine rule. Right. And always try and do things the most efficient way. Can you pretend then that you found that one with the cosine rule, and then you used, that's 120 degrees. You went and used the sine rule to find that's 120. Shouldn't you be able to get that one without doing any real work? Wouldn't the third one be just whatever's left from 180? So always try and think of efficient ways of doing things, right? Well, I don't really need to do the whole thing from scratch. If I know two angles, I get the third one for free. Now, on triangles, this can happen. You're trying to find angle A, and you've got whatever numbers are floating around, right? That's probably unlikely. Make that 170 or something, right? Now, that would be a sign rule question. Would you agree? The information, only the sign rule would work. And this would be little a, I'll call that B and C. This would be little b, and you would be doing sine A over little a. You'd be doing sine B over little b. And you know little a is 170.
Are you going to put this video up like with the classes?
This video will appear just like a normal class lesson, yes.
Okay.
So if you just want to watch and not write, that makes perfect sense to me. Now, what would you do next? I know it's been a while since you did these, but what's the algebra next going to look like?
You cross multiply, so 170 sine 30, and then 22 sine A.
Right, and then off you go and you solve it, right? Now, I want you to imagine that I had a question like this. Just ignore those numbers because I think that one's impossible. And we get this problem. Sine A ends up being nothing 0.123. Then to get angle A, don't we just simply take the inverse sine? And I'll make sure I'm in degrees because almost all of these questions are in degrees. So mode, yeah, I'm glad I checked. There's a little mistake, dead easy to do. Can't you sometimes be in degrees when you need to be in radians, and sometimes you're in radians when you need to be in degrees? So keep an eye open for that. Right now, I'm just going to do it in inverse sine. I'm going to put in 0.123 and I'm going to get a correct answer. Not a great answer, but a correct answer. Let's just call it 7 degrees. Whenever you are doing the sine rule and you are finding a missing angle, isn't there always a possibility, and I'll phrase it that way, always a possibility that there might be a second answer that works? If 7 degrees is one of them, take that away from 180, gets you the other one. Sometimes it's called the complementary angle, right? 7 and 173. Now, based on my picture, if this was really the calculations you got, would you agree that 170 is not feasible in this question? So the only correct answer is the one that you got from your calculator, right? The 7 degrees. Why is 173 in this particular case not feasible?
Because that plus angle B is more than 180.
And that's what you do. But can we pretend? I know I'm doing lots of pretending, but we've done this question again, right? And I'll make this angle here, oh, I don't know, 80 degrees. Then wouldn't this one here would be the other 100? Would 100 degrees be able to work in this triangle? So can you see sometimes there are 2 correct answers and sometimes there's only 1, right? Actually, isn't there sometimes the triangle's impossible? Right? In other words, the triangle with the numbers you gave me can't exist. And what would that look like? Well, you would kind of mentioned a version of that earlier. Couldn't you end up trying to get the inverse sine of 7? Right? And that doesn't exist. So if that was the question, you would say, you know, it's impossible, right? You can't get a triangle with those numbers. I could make one up right now that's impossible. 2, 2, and 100. Would you agree there's no way in the world that triangle could exist physically? But if I use that triangle to find a missing angle, couldn't we easily get to the stage where the calculation would generate a number that's impossible to find the inverse cosine of? And so it could happen. Hopefully it won't. But, well, I spent a little bit of time on some of the things I think students tend to forget a little bit, or they know the rules, but they're not used to which one do you use in which situation. So anybody got a topic, question, whatever you want, you can do that.
I just wanted to clarify that So for the sine, when we use the sine rule, that's when there's a possibility to have another, like that complementary angle, but that doesn't
Yes.
happen when we use the cosine rule, right?
Correct. The cosine rule is so much easier to use.
Okay.
The one answer you get is the only answer in town. Then I make life easier. You don't need to look for another one because there isn't going to be another one. Fine. Don't even try and find.
Will the question tell us if we need to look for the opposite angles? in the
No.
sine rule? Okay.
No. Your
So we
job
just
is
have
to
do
know.
that. Okay.
Right. So what I suggest you would do is you'd write down two angles and then you'd cross one out. And that crossing out means to me, you knew that one was impossible, right? That would be how you would show me that you knew it was impossible. You'd write it down to show me you knew it existed, and then you cross it out to say you can't use it, right? Does that make sense? Rather than just write one down and say, I did it in my head, because couldn't that mean is I didn't even know to look, but I got lucky and the other one wasn't usable, right? So you have to kind of show me that you know that you looked for it, even if you end up crossing it out at the after that and saying it's not possible. Chris?
Also for showing your work, do we need to, like, if we know two angles of the triangle and it's obviously you just subtract them from 180 to get the other one, can we fill in the other angle, or do you want us to write out? Like,
what I would like is for you to say that little calculation. And it doesn't take long to write down. The reason why I want you to do that is, have you ever had a test where you knew how to do it, but in your head, for some reason, it turned into 50 because you can't count when you're under stress, and you just write 50 down, but no indication of where it appeared? Now, if you wrote that down and said 50, I'm just going to look and say, oh, she knows what they do. She just, drifted a second, right? It's safer to show me working, because when you make a mistake, if I can see what you were doing and what you were doing is correct, even if you finally said that was 50, you don't lose that many points, because I'm sure what you did, because I know you know how to count, right? I'm sure all you did is got, the excitement and stress of a test tends to make people careless. And so I can say, I'll take a point off, she can't count. God, if you took points off every time I made a mistake, God, I'd be in trouble, wouldn't I? Right? But it's not that I don't know how to do the process, right? It's just that I'm too busy thinking of the next two lines that I don't always think about the line I'm on. So that might be good advice for you as well. For tests at least, will you think about the line that you're on before you lose track of what you should be doing next. Okay, well, I'm looking for another question.
Can we
Good.
go over reference numbers of an angle?
Yes, reference numbers.
Are there any questions on the test where we're going to need or be able to use Desmos?
I'm giving you Desmos because sometimes it just helps to see it. The kind of questions I'm talking about are, do you know the ones where you have y equals 3 sine x minus pi upon 2, and you want to know what the phase shift is, or you want to look at it, or maybe you want to sketch it? Desmos is helpful, right?
Okay.
So it's there more as a tool, something to help you, right?
All right, but we're allowed to use Desmos in the test? Yeah,
it's going to be there. In that little module that I've got, Desmos is inside it. It better be now. It's inside it. Everything else will disappear, but whatever is inside, you can use. Right. Okay. So let's suppose I found an angle like 135 degrees. And I'm doing degrees mostly because they're easier for me to do in my head, but the same thing I'm about to say is true if you do it in radians. Right. Now, if you did 135 degrees, would you all agree that it's basically that angle there, right? Now, what's this angle in here? How big is it? Or you can always tell me the calculation to get that angle. What's the little black angle?
45 degrees.
Yeah. Right, 180 take away that one. It's 45 degrees. Is that the kind of question you want me to go over? That kind of question? I can't remember who asked.
Yes.
Right. So what we are looking at here is, if you have an angle here, I'm just picking 30 degrees as an example. There are 4 angles that fit, and they all make 30 degrees with the x-axis. And we use this reference angle thing very often. We use it to find the second answer, right? The second angle in a question. So, for instance, suppose I told you that the sine of theta was a half. And I asked you to tell me who theta was. Well, if you go to your calculator, you'll get in degrees, basically inverse sine of a half. Well, I could have got it from my unit circle. Actually, maybe the next one I'll do my unit circle. You get the answer, it's 30 degrees, which is quite correct. But there's typically 2 answers to that puzzle. Remember when we did the triangle and we said, look, one of them's 30, but they had the other one, remember the complement angle? Complement angle is just another example of a reference angle. Where in the world, which quadrant is the other place where a sine is a positive thing? Which quadrant is the sine positive? Or which quadrants?
The second and the first.
Second. Now, when you go to the second quadrant, you make the same angle, 30 degrees. And now we can figure out how big that one is. And the second answer is 150 degrees. And I'll go here and check it. The sine of 150 degrees better be 0.5. Well, suppose we do the cosine of theta is nothing 0.3. Let's pick a really ugly one. Then the calculator is going to give me one of the right answers, which is good. So inverse cosine is 0.3 is that guy. And I'm just going to pretend the answer is 73 because it is the nearest whole number. If I draw my little guy, 73 is here. But there are some other places. Which quadrant is the cosine positive? You know it's positive in the first, but what other quadrant is it positive in?
The 4th quadrant.
You remember this thing? All sine tan cos. Right, that's how you can remember. Right, now the angle that goes here, the reference one, is 73, right? But we don't call it 73. We don't even call it negative 73. We call it whatever that is. So this angle is 73, but we measure it in this anti-clockwise direction. So it would be what, 360 take away 73, which is what, 287. Let's put a negative into this. Let's suppose we have that the tan of theta is -4. And again, I'm going to go inverse tan to find out what the angle is. So theta is the inverse tan, -4. And I'll call that.
You did 4.
Oh, I put 4. Let me do that again. Thanks for catching that. -4. And you're going to get a weird answer. It's -76 degrees. We don't want negative answers. We only want answers in the range 0 to 2 pi. What I typically do in these questions is I visualize it. I draw what -76 would look like. -76 just means you go down the way, right, clockwise, instead of anti-clockwise. So the reference angle is still 76 degrees, right? Right, you just go down 76. Now, what's that angle, which is actually the ones we're going to use? This is 76. How do you find that angle?
Subtract 76 from 360.
Agreed. And that ends up being 284 degrees, which is good. And then I'm going to do, I wonder where the other answer is, because there's two of them. And I have all, sine, tan, cos, right? First quadrant, second quadrant, third quadrant, fourth quadrant. Where else is the tangent negative? Which quadrant is it in?
Third quadrant.
Say that again?
Negative, sorry.
Yeah. So which quadrant is it in? Which quadrant is the tangent negative? Let's phrase it that way.
The second.
The second. Now, if you remember the 4 reference angle things that look like this, the guy we want in the second quadrant has an angle here of 76 degrees. So if I just draw what we have here is that bit there is 76 degrees, right? And the second angle then, always measured from 0 going that way. If you want that angle, won't you have to take 180 and subtract 76 from it? And that leaves us, I believe, with 104 degrees. So what this whole process does is that it finds a way for us to find both angles that satisfy sine of theta is this, cosine theta is this, or tan of theta is this, right? Because in those 3 situations, right, we know there's 2 answers. Unfortunately, the calculator only gives us one, and doesn't it sometimes give us one that we don't even want to use? Now, who knows, 10 years from now, 50 years from now, someone is going to invent a calculator where you just type in inverse tan of -4 and it tells you the 2 answers with a comma between it. Won't that be great when they do that? And see, the minute that happens, we will stop teaching you about reference angles, right? Because we'll have found a much easier way to do it, right? But until that day happens, we have to kind of fight our way through. Now, I want to just prove that this is the case. Now, you know, I've rounded this off a little bit, so don't be surprised if it's not exactly -4, but shouldn't the tan of this be darn close to -4, right? So let's see what it is. If you do the tangent of 104 degrees, the answer is, would you agree that's darn close to -4? So haven't I kind of proved that I've got it? Actually, can't you use that as a quick check that you've done it right yourself? So if you think it's this answer, why don't you just find the tan of it? If it matches what you think it should be, you've got it. If it's not the guy, oh, maybe it's the second quadrant. I was looking in the third, you know, and so on. Did that help?
So questions like these will have multiple answers, or is the final answer like the last one, the 104?
No, in this case, you're being asked to find the solutions to this. So there could be multiple answers. It depends on the context. You know, if you're doing a triangle question and there's 2 answers, but only one of them works, then that's a 1 answer question because there's a triangle attached to it. But see if it's just tell me the angles that this works for in the range 0 to 2 pi, do you see it's now a 2 angle question? Right. So it depends on what the question is. If it's a physical triangle, there might be 1 answer, there might be 2. Right. If it's one of these guys, there will be 2. I think we should finish with a joke. Is anybody here going to become an engineer? Because the joke is picking on engineers, so I want to make sure that I'm at least picking on one person.
Yes, but I don't care if you tell it.
Okay, good. So Olympic College had a competition with two of the universities in Washington State, and it was the engineer department, and the students had to design from scratch an aircraft. Right, write down the plans of what the aircraft would look like and so on, and the measurements and everything. Right, and it's a big project, and Olympic College and the two other universities meet up at SeaTac Airport because they were going to find out who won, who won, they get a prize. And the only people who came were the professors of each of these three places. And they're all sitting down, three of them. And the guy who ran the competition from Boeing comes in and he says, well, it's an interesting competition, but we do have a winner. And it says, and as a special prize, what we did is that we actually built the plane using the specifications that your students gave us. And you're actually in that plane right now. Well, the OC professor was sitting in the middle, and the other two professors scream and shout, and they climb all over him, and they run out the plane, down the gangway, screaming and running as fast as they can. And the OC professor just sits there with a big smile on his face. So the Boeing guy says, why didn't you run away? And he went and says, well, I know that if this was done by my students, there's no way in the world this aircraft is ever leaving the ground. Okay, have I suitably insulted you, Aaron?
Not in any way.
Okay. Right, have a nice weekend, everyone, but not too nice a weekend because you are studying for your midterm. And it's a good idea to not study for too long. Have nice breaks, right? Go and watch a TV program or a movie or take your dog for a walk and then come back. You learn more if you have rests.